So last time, we went over some definitions. So one was population and sample, right? Population was all, right? Population was everything you're trying to study, all. And a sample was just some subset of that. So we'll just say this is some, right? Some of them, but not all. Populations are hard to get. So if I said, I surveyed 1,500 U.S. teenagers. Well, is 1,500 U.S. teenagers, is that all the U.S. teenagers? No, so that's the sample. It doesn't say it's a sample, but you got to kind of make that connection, right? So the 1,500 is the sample, and then the population would be all U.S. teenagers. Right? It's not going to tell you that's the population. You have to, figure that out yourself. And then if we calculate something for a population, or we figure out some characteristic of the population, that's called a parameter. If I said, the average height of U.S. teenagers was 5 foot tall, then that would be a parameter. But if I said, I couldn't measure all the teenagers, that would be crazy. I found 1,500 teenagers, and I measured their heights, and the average height of the 1,500 was 5 foot tall, then that 5 foot tall would be a statistic. So parameters go with population, statistics go with samples. We want to take a sample that's representative. We hope that the statistic will be close to the corresponding parameter, right? If the average height of U.S. teenagers will be the parameter, the average height of my sample of U.S. teenagers will be a statistic. I want those to be close, okay? But they will not be the same. Okay. And then we talked about types of data. So we had qualitative and quantitative, right? Qualitative are qualities or like categories, characteristics. Quantitative data are numerical quantities, right? They're numerical and they have to represent how much of something there is. They have to be quantities. Qualitative data can be numerical, like zip codes, social security numbers, your street number, things like that, your A number. So those things are qualitative, but they're also numerical because they don't represent how much of something there is, or a numerical measurement or quantity. And then under quantitative, we have two subcategories, discrete and continuous. So both of these are quantitative. Discrete data is data that you get by counting. And continuous data is quantitative data that you can't count. You have to do something else. So usually if it's measured, then that means that it's continuous. If it's counted, that usually means it's discrete. So discrete data would be like number of home runs you hit in a game, number of birthdays you've had, how many students registered for class. And continuous data would be things like height and weight, lengths, volume, GPAs, average salary. Anytime you take an average, it's going to be continuous. Okay. That's where we finished. Am I right? Any questions about this stuff? Okay. So that's 1.1. So I'll put 1.3, 1.4 together. We're just going to call it sampling techniques. So we want to collect data. We want to collect samples. We're going to try to do this in the proper way, in such a way that we want our sample to be representative of our population. So here are techniques that we can use to achieve that. So again, we're going to have some more definitions. So first one is random sampling. So what does it mean if you randomly sample? So it means you choose by chance. So you're using chance in such a way that each individual member of the population I don't know what that is. That's not population. Each member of the population has an equal chance of being chosen. So if everybody, or every element, everything that's in your population, every individual, if they all have the same chance of being picked for the sample, then you have achieved random sampling. And random sampling is the gold standard for taking a sample if you want it to be representative of your population. It is not guaranteed to be representative, but it gives you the best chance. It gives you the best, it's the best we can do to try to achieve a representative sample, a sample that's going to look like the population looks. Okay? So, I've got a book. Let's pretend this is the phone book, okay? And I said, I want you to pick 25 random numbers and call them and give them a survey. So how are you going to pick 25 random numbers? How are you going to pick them randomly? Open it up.
Try to not choose from the same first letter of the last name.
Okay.
Same area.
Try not to pick from the same area. How do I pick the page? How do I do that? Just kind of open it up somewhere? In the middle? Okay, let's say that we tried to pick a random page. Would we pick the first page? Or the last page? We're supposed to be able to. But I think most people would try to pick one in the middle. Somewhere in the middle, right? Because somehow that's more random than the first or last page. But that's not according to our definition. So according to our definition, the numbers on the first page and the last page have to have the same chance of being picked. Okay? All right, let's say we picked our page. How do you pick the number? Close your eyes and pick, right? Well, I think if you did that, then the numbers like in the middle of the page would have a higher chance of being picked than the ones at the very top, at the very bottom. Does that make sense? So that, what we just talked about is not really random sampling. It's very difficult for humans to achieve randomness by making decisions ourselves, like by interjecting ourselves into it. He said try not to pick from the same area. If you do that, you're not picking randomly. You let everything fall where it goes. Okay. Apple, when they came out with the iPod, they created the shuffle feature, right? It would shuffle your songs in a random order. And customers complained because they got too many clusters of songs by the same band. You know, they'd play too many songs in a row by the same band, like 2 in a row or 3 in a row. So they complained to Apple that their algorithm wasn't working, that wasn't random. And in fact, they had programmed it to pick truly randomly. So they went back and made their algorithm choose less randomly so that it would appear to us that it was more random, because we just can't, it's hard to get our brains around what randomness really is. So if you were to pick numbers from a phone book randomly, truly randomly, some of them would cluster on the same page or the same area, right? Because you don't have any control over what happens. It would not be evenly spread out through the phone book if it was truly random. Does that make sense? So how do they pick the lottery numbers? They put them in that basket, right? And they turn the basket and they pick a ball out of the basket after it's been shuffled, right? So that is pretty good. That's about as close as you can get to randomness, right? You could write down all the numbers of the phone book on little sheets of paper and put them in a hat and shuffle them up, or a bag, and pick them out of the hat. That would be random, okay? That'd be as good as you could do, okay? But if you yourself have any control over how they're picked, you're not going to be able to achieve randomness because it's too hard for us to do, if that makes sense. Okay, we can't just come up with random things or random choices out of our brain, because our brains go through the system of logic, right, to come up with the choice. So if you interject yourself into the process, it messes up the randomness. Okay. So there's another type of random sampling. It's slightly different. It's still random, but we're gonna have an extra condition here. It's called simple random. It sounds simpler, right? But it's actually got a little bit more to it. So if you take a simple random sample, every sample of the same size has an equal chance of being picked. As opposed to every individual in the population, if you're going to pick, say, I'm going to pick 25 random phone numbers, right? If it's simple random, then every sample of 25 phone numbers, all of the possible samples, they all have the equal chance of being picked. Okay? So simple random sampling, you're going to choose by chance in such a way that each possible sample of the same size has an equal chance of being picked. I'll say of being chosen. So random means every individual has the same chance. Simple random says every sample of the same size has an equal chance of being picked. They sound like pretty close to the same thing, but they're not. So it turns out Simple random sampling is also random. Every sample has the same chance. Every individual has the same chance. But not all random samples are simple. So let me give you an example. Let's say instead of just any phone numbers out of the book, I say I want you to call 5 women and 5 men. I want you to pick 5 random women and pick 5 random men for a sample of 10. So does every sample of size 10 have the same chance of being picked? You're going to pick 5 random women and 5 random men. Does every sample of size 10 have the same chance? Let's back up. Does every single person have the same chance? Yeah, so it's still random. But it is not simple random. So why is that? So what about those samples that have 3 men and 7 women? Can they be picked? There's 3 men and 7 women. Can that be the sample that you pick? No. Those samples have a 0 chance of being picked. They cannot be picked. Right? Only the samples that have 5 men and 5 women can be picked. So they all have an equal chance, but all the others that you could get, 1 man, 9 women, 8 men, 2 women, all of those have no chance of being picked. So it's not simple random. And we call it simple random because you're not interjecting a process into your choosing. We added something here. We said we're going to split this up into 5 men and 5 women, so it's not simple anymore. You're not just simply picking 10 random numbers. You're putting in a process. Okay, and this process has a name, so it's actually it's another sampling technique that we'll do next. Okay? Any questions? Okay, so that technique we just did is called stratified. Stratified sampling. You're going to divide the population into groups. So what I did is I divided my population into men and women. All right, divided it up. And a simple random sample from each group. So when I picked my 5 random men, that was a simple random sample of just the men. And when I picked my 5 random women, that was a simple random sample of just the women. When I put them together, though, it's not a simple random sample of them together. It's called a stratified sample. I divided my population into 2 groups. You can divide it into more. And we sampled from each group. And the randomness of the sampling makes it random. Every individual still has the same chance, but each sample doesn't have the same chance. Okay, so it's still random, but not simple random. We've supplied an extra step there. Okay, next is called cluster sampling. It's very similar. It can be very confusing. but it is different than stratified. You're still going to divide the population into groups. Divide the population into groups. You're going to take a simple random sample of groups. So usually when you do cluster sampling, you divide it into many groups. There were a few of the groups randomly. So I'm going to pick groups, not individuals. So I'm going to take a simple random sample of the groups and collect data from each individual from the groups chosen. So you divide up your population into a bunch of groups. You pick a random sample of groups, and then once you pick the groups, you're going to take a census of each group. You're going to collect data on every single member of those groups. So I could say, let's pick 10 random counties in the state of Tennessee, and we're going to go check the gas prices of every single gas station in those counties. Okay? We're not going to sample once we've picked the groups. The sampling comes in when we pick the actual groups. We're going to pick random counties. Those are our groups. I'm not going to go to every county. Just going to pick 10 random counties, and I'm going to go and collect data on every single thing in the county that I'm trying to study. Right? So I'm going to go check the gas prices at every single gas station in those counties. If I was going to take a stratified sample with the same scenario, I'd say let's go find 5 random gas stations in every single county. I'm going to sample every county and get a sample, not go to every single gas station. Okay. Does that make sense? Okay, so if I told you to go down the hall and pick 2 random classrooms and survey every person in those classrooms, what kind of sampling is that? That's cluster. If I said go down the hall to every classroom and pick 5 random students to survey them, what kind of sampling is that? Stratified. Right. You sample from every group, that's stratified. If you just pick a few groups and you survey all in those groups, that's cluster. Okay? Any questions? All right. Next is systematic. Yes.
I'm just having trouble seeing the distinct difference between random sample and simple random.
Simple random is every sample has the same chance. Every group of things that you're picking has the same chance. And in random sampling, every individual has the same chance. If we do a stratified or cluster sample, it's random. Every individual has the same chance from the beginning. But not every possible sample has the same chance of the same size. You know, if I do a cluster sample of those gas stations, right? Samples that contain prices of gas stations outside of the counties that I picked cannot be in my sample. Does that make sense? Because I'm only going to pick from these 10 counties that I chose from the beginning, right? Those can't be picked. So, or samples that have a gas station from every county, that has no chance of being picked from the very beginning, right? Because we know we're not going to go to every county, right? So, samples are groups of things, and individuals are just single members, right? All of these methods I just talked about are random. Every individual has the same chance from the beginning, but not all the possible. You can't get every single type of sample in some of these, right? So if you can, though, that's called simple random. It's simple random if I'm going to take a sample of size whatever randomly. That's it. That's why it's called simple. Okay? All right. Systematic. You're going to choose a random starting point less than some number k and pick every kth element after. So let's say we're going to do the phone book again. And I'm going to say I want to pick every 10th number in the phone book, but I want my selection to be random. I want to have a randomness so every phone number could be picked from the beginning. So I'm going to say let's just pick a random number less than 10. So let's say we picked 7. Okay? So I picked my number 7. So the 7th phone number will be picked, and then every 10th number after that will be picked. So the 17th and the 27th and the 37th. Yep.
Can you tell what the last sentence say?
And pick every kth, KTH, element after.
Okay.
So k is some number, so it could be 10. I said 10, so it'd be the 10th instead of kth. Right. So we pick, how the k is how spread out your data is going to be, in the phone book if you're doing the phone book, right? So if we say let's pick every 100th number, then 100 will be your k, and then we'll pick a random starting point. We'll say pick a number less than 100 randomly. If it's 58, then we'll pick the 58th number, and then we'll count by 100 after that. So we'll pick the 158th, the 258th, and the 358th, and so forth. That's called systematic. You're creating a system that picks the numbers automatically, really. Right? You're picking a system that picks them automatically. So, random, simple random are good. Cluster, stratified, systematic are good. Stratified, cluster, systematic, and simple random are all random. Okay? From the beginning, at the very beginning, before you start, every individual has the same chance. Okay? But not every sample has the same chance unless it's simple random. The next one is not a good one. Okay? So the next one's one that we wouldn't want to use. And that's convenience. Convenience sampling. So convenience sampling is obtaining data that is easy to get but may not be representative of the population. Obtaining data or obtaining a sample that is easy to get but may not be representative of the population. So if I were to say, all right, your homework assignment is by Monday, I want you to take this survey and give it to 25 random people in the state of Tennessee. Okay? Now, who are you going to give the survey to? Say what? First people you see, your friends, your family members, right? Whatever you got to do to get the assignment done, and you don't really care if it's good data or not, right? You're going to give it to your coworkers. You're going to probably give it to more people in the Chattanooga area than you would somewhere outside, because it'd be more difficult to go to Memphis or to call somebody in Memphis to get them to take a survey. So that would be a convenient sample. So your data is pretty much junk if you do it that way. Okay? So, you could analyze the data, but the only thing it would be useful for would be to your circle of friends and acquaintances. It wouldn't be good for, you couldn't extend that sample to the population of Tennessee. So, I think it's easy to think about. Your circle of friends and acquaintances and coworkers is probably not a good representation of the entire state. Okay? So, that would be convenience sampling. So we don't want to do convenience sampling. Another convenience sample would be, if you go to CNN.com and take one of their online polls that they have on their front page. So what's wrong with that? There's nothing wrong on your end. You're just doing the survey. What's wrong with it on CNN's end? I'm sorry? Not everybody goes to CNN, right? So they're only getting data from their customers because it's easy, right? It's only people who go to CNN.com that's taking this survey. People who go to Fox News aren't taking that survey, so they're not getting a sample that's representative of the entire population of citizens. Now, they are getting probably good data on their customers that visit their website. They know a lot about them. They don't know a lot about anybody else. So it's just a convenience sample. Okay. Other types of sampling that's not good, I'm not going to write it down, but there's something called voluntary response sample. Let's say, if the individuals in the population get to choose whether or not they're in the survey, that's called voluntary response, and that's not good. So, for example, you've all seen those comment cards at the restaurant table, right? You fill out the card, you tell them how things are going, and they're collecting that card. They're collecting data, right? It's a survey. So who actually fills out the card, though? Customers who what? Right. It's either someone who's really mad about what happened, something went bad wrong, or it's somebody that's just really happy about what happened. It takes someone who has strong feelings about the survey to actually do the survey. If you just went and everything was normal and everything was just okay, you don't feel compelled to pick up the card and tell them, hey, it was just okay, right? So they only get the really good and the really bad. And maybe that's all they want. maybe that's all the restaurant cares about. But it wouldn't be representative of their entire customer base, their entire population of customers. So voluntary response samples are not good. At the end of the semester, you'll get to take a survey and evaluate how the course went. And how good was the course, how good was the teacher, and all that stuff. And the response rate is really low. We would like to make you take that survey, but we can't. I can't put you in prison if you don't take it. Like I can't force you to do it, right? I mean, I could make it a grade or something, but that would be influencing your answers on it. So I don't want to do that, right? So the comments that I get, some people write comments. Who writes the comments? The students who are really, really unhappy with the class and what happened, or mad at me, or they just loved me and they just want to let me know how much they love the class. And the stuff that I really want to know is like, this thing worked and this thing didn't work so well. You might do more of this and less of that. I mean, I want that kind of criticism. I love it when people tell me they love me. I don't care, I don't want you to hate me, but I don't take it personally, okay? And, I'd rather have the constructive criticism so I really do read those. They're anonymous and all that, but I just don't get enough of them because you guys decide. All the students who just thought the class was fine, they don't make comments, and or they don't even take the survey at all. So those things are kind of not very good. They're not very representative, okay? And the bad sampling techniques create what's called bias. So this word is called bias. All that means, if a sample is biased or has bias, it means that it's not representative of the population. Okay? It's skewed one way or the other, And you can tell, like if you know the population parameters, you can tell if your sample has bias because your actual statistics won't be close to the parameters. If you know the average height of males and you take a sample of males and you get a really, really high height average, higher than normal, right? Then maybe your sample is biased, okay? Maybe you shouldn't have, taken your survey to the basketball team. That would have skewed your data on height, right? So that's what can happen. And people can intentionally do this, create the bias so the data will tell the story that they want to tell, okay? So you always need to be conscious of that. Where did they get their data? Who did they survey? How did they do it? The questions themselves can create bias, If I asked a question like, do you support defense funding, or are you in favor of cutting veteran benefits? Right? That is a terrible question. That will skew the answers in a certain way because nobody wants to cut veteran benefits, right? So that's going to kind of force you to answer it the other way, right? It's called a loaded question, right? It's not worded. It's not worded balanced either. It's not a balanced question. Any questions? Okay, we're going to do something real quick. What I need you to do is, if you're in eLearn, go to stay in eLearn. If you're in MyLabs Plus, stay in MyLabs Plus. So in eLearn, there's a link on the front page. It's called In-Class Polling Link. You can click that. And if you're in MyLabs Plus, that same link is in the Course Information tab. If you go to Course Information, it's right there. So you can always click this link when we do this. And I'm just going to be able to ask you some questions. We're just going to see how good this is. So let's see if it happens. You might want to refresh, or you might have to put your name in there. You can also do this on your phone. The website is up here, polev.com/AaronWillman383. That's always going to be the website. It doesn't change. And you can text message too. The text messaging didn't work so well last semester, but the website works pretty good. Even on your phone, it works pretty good. One question for now. Yeah, I'm going to ask you more. So this says that, it's like I need to move this thing out of the way, don't I? A survey of 200 adults in the U.S. found that 76% regularly wear seatbelts while driving. True or false, 76% is a parameter. So is it a parameter? So you can use your phone, you can use your tablet, you can use your laptop, or you can just use the desktop, it's fine. The desktop will take a while to log in sometimes. So that should be the first thing you do when you come to class is log in the computer, and it might take a while for it to load, but you should have time before we get to some of the stuff. We're going to do a lot inside of MyLabs Plus 2. We're going to use StatCrunch. I'm going to show you how to do StatCrunch. We're going to do all that together. You'll have to be logged in to do that. So try to log in as soon as you get to class. So I'm just going to give you a couple of minutes. So what?
Is all this going to be on our first test, sample population?
Oh, yeah. We just got started, man. We got 2 more chapters that'll be on your first test. Click that link, M-Class Polling. See that? Yeah. There you go. This thing's in the way. All right, let's see what you said. So 90% say it's false. 10% say it's true. The answer is false. So it's a parameter. No, it's not a parameter. It's not a parameter because it's the 76% is from the sample, right? It's actually a statistic. So parameters go with populations. Statistics go with samples. Okay, so that is a false statement. Okay, next question. The checking account numbers of customers at a bank represent quantitative data. True or false? The checking account number. Click on my class. No, the other one down here. Yeah, that one. In-class polling. So your account number at the bank, is that quantitative or qualitative? Sorry.
It's under links.
I'll just put it on the home page right there. Sorry, excuse me. Okay. 71% say false and 29% say true. So the account number at your bank, does it represent how much of something there is? No, it's not a quantity, right? It's just a code that tells the bank where to put your money, right? It's not your bank account balance. It's the account number at the bottom of your check, right? That the account number tells the bank where to put your money. So that is false. So that's just like a zip code or telephone number. All that stuff is numerical, but it's not quantitative, it's qualitative, right? Everybody okay with that? All right, we have 24 students registered for this class. This is discrete data, true or false? Discrete, is it discrete? All right. So 87% say true, and that is correct. So 24 students, how would we get that number? We would count how many students there are, right? That's the only way to do it. So that's how we obtain that number 24. So that means if it's counted, it's discrete, okay? And you can stop me if you have questions. You can interrupt. It's totally fine. All right, identify the type of sampling used. Students at a university are classified according to major. The administration randomly selects 5 majors. All students majoring in those 5 areas are surveyed. So 5 majors are randomly selected, and all students that have those majors are surveyed. All right, let's see what you guys said. So 79% say cluster, 7% say stratified, 14% say simple random. Well, it changed. That's okay. So it's actually cluster. So in cluster sampling, you divide up into groups. So their groups are all their majors. All the students in their different majors. So the majors represent the groups. If it's stratified, they're going to sample from each major. They didn't do that. They took a random sample of 5 majors. They picked 5 random majors, and they went and surveyed all the students who had those majors. That's called cluster. If they just said, let's just go survey 100 students randomly, that would be simple random. Okay? Any questions? All right. So let's look at, oops. There we go. If I go to MyLabs Plus and I click on homework, it'll show me all the homework assignments. Well, it's supposed to. Let's see if it does. Yeah. If I click up here where it says homework, this link at the top, this drop down, I can click all assignments and it'll show me the quizzes and the tests as well. Okay, and it'll show them to you in order. This on the left tells you the due dates. So there's a survey that you take. It's no big deal. You just go in there and you answer questions and you submit it. Okay? And then 1.1, 1.3, 1.4 homeworks are going to be due Tuesday. And look at the time stamp on the due dates. It's midnight. Okay? So you're going to do these homeworks. You need to have them done by Tuesday before class. And then during class, the first thing I'm going to say is, are there any questions? And you can say, yeah, I couldn't do whatever number on the second homework, and I will pull it up and I will do it. Okay? And then you'll have a chance by midnight, Tuesday night, to fix it. You know, get it fixed yourself. Again, you have unlimited attempts on the homework. Okay? And then if you don't finish something by Tuesday, you get assessed a 10% penalty on whatever you don't finish. Okay, if you finish it later. Right? Any questions about that? Yeah.
If we do the homework, can we do it again afterwards? Like I've done it and it has like green check marks by all of it, but it still doesn't say
Okay. If you let me clear this. So if you see all the questions are here on the right side, they're all worth 10 points. Okay? You're also assigned these things. So this is the textbook, because I want you to read. Okay? All these are videos. They're usually very short. That's actually a textbook too, right there. That's 1.4. I want you to watch the videos, so you get a point for each one of those things. So you can't make 100 unless you do those things. Okay? But they're worth a lot less than the actual problems. You know, it's 5 points out of, let's see, I don't know what it's out of. Let's see. Yeah, out of 69. There's 69 points on this homework. So 5 of those are the videos and the textbook. So I want you to get used to looking at the textbook, looking at the examples in the textbook. I want you to watch the videos. The videos will have examples. Some of the videos are actually the author of the book explaining the stuff. I think he's really good. I've met him. He's a nice guy. So just, I want you to do that as part of your preparation for the homework. I would watch the videos, look at the textbook before I did the homework. Okay. I'm also going to post the video. Let's hope it works this time. I'm going to post it in the YouTube playlist. I'll post the link and let you guys know about that link. Okay? Any questions? All right. You know, I've got office hours. The Math Center will help you. You know, the Math Center's open a lot, so take advantage. And we're out Monday. And the Math Center will be closed Monday, and they're going to close this Saturday, so they have a long weekend. And then they'll be back to regular schedule on Tuesday, okay, for the holiday. Any questions? Okay, I'm going to hit stop.